Alright folks, today we're working on 1.3, which is our absolute value equations. So first off, let's remind ourselves what absolute value is. The absolute value is defined as the distance away from 0. And that's just the center of the number line. So let me just lay a number line down here. Let's talk about this a little bit more. So put the 0 in the middle of it, because that's usually where 0 goes. Let's see, I'm going to count by 2s with little tick marks, the ones in the middle. 6, let's see, there's 8. Let's go backwards as well. So -2, -4, -6, -8. Plenty of number line space. So if we were kind of thinking about this, I also think about absolute value with this keyword of distance. Like if we say that we are at the 2, right? So we say the absolute value of 2. That's going to be, well, we've got to get distance away from 0, so we can take like 2 little jumps, get us back to 0. It's 2 units away from 0. So let's see how it's different from, say, -2. So absolute value of -2 is equal to distance away from 0. It takes us, again, 2 steps to get back to 0, which is funky. We've got 2 numbers that give us the same result, which says that when we are looking at equations down below, we're going to have multiple solutions because multiple of them are going to work. We could do this over and over. We could say absolute value of 4. So absolute value of 4 is going to equal 4 because if you count it, it's 1, 2, 3, 4 units away from 0. And we could go on and on, do the same thing over and over. So let's think about where it goes in the order of operations before we move on to these equation things. So if we have like, I don't know, 2 plus 5 inside the absolute value, and then like -3, order of operations puts absolute value with parentheses, and they kind of look like where parentheses would go. They're around the thing. So do the stuff on the inside first. So 2 plus 5 is going to give us 7. And then take the absolute value of that before you move on. So absolute value of 7 is 7 units away from 0. Yep, all the way. -3 gives us 4. So when you're trying to simplify these things, it acts exactly like parentheses. It's not a big deal. Just do the stuff on the inside first, just like you would for parentheses. Okay, so example 1, solve for all solutions to x. Remember up here we talked about how there were 2 different solutions for the same number. So absolute value of something, our unknown, I'm just going to put my finger over that for right now, the absolute value of something equals 5. So look back at the number line, we're asking what number can we put in here to get 5 as a result? And if we remember from our 2's right here, we're looking for something that's 5 units away from 0, because it's equal to something that's 5 units away. So if I count from 0, I can count to the right, 1, 2, 3, 4, 5, puts us at 5. If I count to the left, I can also count from 0, 1, 2, 3, 4, 5, puts us at -5. So that says the stuff that's on the inside of the parentheses has to either equal 5 to get us to this right unit that's 5 units away from 0, or it has to equal -5 because we can go backwards 5 directions, and that's also 5 units away from 0. Unfortunately for us, the stuff on the inside of this absolute value is just x. So the statement we can say, it's like, look, you substitute in 5 here, you get absolute value, so this is our checking area. Absolute value of 5 is supposed to equal 5. We know the absolute value of 5 does equal 5, so yes, this is a true statement. We can substitute the other one in. The absolute value of -5 is supposed to equal 5. So we can say, hey, absolute value of -5, total equal 5. And again, we get 5 again, because -5 is, again, 5 units away from 0. So that one's not a big deal, but let's look at something like example 2, where we have something else other than an x on the inside of the parentheses. So let's multiplying by 2, so we've got absolute value of 2x equals 14. So we're looking for something, and probably multiple somethings, because like the last one and then from 2 is up here, that are 14 units away from 0. So 5 is both +5 and -5, because both of those are 14 units away. So 14 is going to have both 14 and -14, because if you were to count in from +14 and -14, you would have 14 units away from 0. So we have to say the stuff on the inside of this of the absolute value, kind of parentheses looking thing, has to be either equal to 14 or -14, so that when we take the absolute value of either of these numbers, we get +14 as a result. So we have 2x and 2x. That's not going to change on the inside. So we're going to divide by 2 for both those. X is going to equal 7, or x is going to equal -7. And again, we can check our work by plugging it back in, just like we did up here for example 1. I think it's unnecessary. So let me just make sure that that's an equal sign. So here's the thing that's to me kind of weird sometimes about absolute value. So example number 3. We have the absolute value all by itself. We're going to say the stuff on the inside, so some absolute value has to equal, let's make sure it's real clear, negative 14. So think about this for a second. When you're going from your house to school, or from wherever you go to wherever you go, at what point do you ever say, I'm going to have a negative distance? And more than that, we can look up here further for our examples. Whenever we take our absolute value, we're never left with a negative number. So we can try to plug in 7, right? Let's just plug in 7 because these problems are real similar. So the absolute value of 2 times 7 should equal negative 14. So 2 times 7 is 14. But absolute value is not going to be a negative. It's always going to be a positive because wherever you go, distance is always going to be a positive thing. So absolute value of 14, this side is 14 units away from 0, so it's equal to 14. And 14 is not equal to negative 14. It's not the same number, not in the slightest bit. They're 28 units, well, 28 units away from each other. So this is not a solution. 7's not going to work. And likewise, when you plug in negative 7, you're going to have almost the exact same thing. You have 2 times negative 7 is going to be negative 14. Negative 14, the absolute value of negative 14, it is 14 units still away from 0, so you're going to end up with the exact same statement. So what we can say is if you have isolated the variable, so if, not the variable, if the absolute value equals a negative number, then no solutions. Because you can never, ever have a number or an absolute value that equals a negative. It's never going to happen. Alright, example 3. So example 3 is where it starts to get a little bit interesting. We have the absolute value of 2x minus 5 equals 15. Well, when we had absolute value just by itself, remember we could like split it apart basically. So we'd have stuff on the inside, stuff on the inside. We'd have a positive version of that and a negative version of that because the absolute value of both 14 and negative 14 would give us that. So we're saying the absolute value of something minus something else is supposed to give us a number. Well, I don't totally know how to deal with that, but I do know that from like 1.1 or 1.2, I know that I could just move this 5 to the side. So let's maybe move this 5 to the side by adding it on both sides. It's going to cancel on the left side. Well, the absolute value of 2x equals, let's see here, 15 plus 5, that's usually 20. So now we're saying the absolute value of some stuff has to equal 20. We know there's two values for that. We know the absolute value of 20 could come from 20. We know the absolute value of 20 could come from negative 20. So 2x equals 20 or 2x equals negative 20. And we can solve this again by dividing both sides by 2. So that's going to cancel. We're left with x equals 10. It's going to cancel over here. X equals negative 10. And sometimes this will happen. You'll have the same value, just one's they're very similar. One's got a positive sign and one's got a negative sign. But it's not always going to happen. So we're going to work some more problems when you get your practice papers, so make sure you grab that thing. We'll work some of these together. But here's the scoop. If you do not have the absolute value by itself, so if absolute value is not isolated, then isolate it first. Alright, if there's anything you didn't get, make sure you go back and look at that part of the notes or listen to what I'm saying.